At exactly 2 p.m. on December 5, 1945, at the Naval Air Station Fort Lauderdale in Florida, USA, a squadron of 5 TBM Avenger torpedo bombers fired up their engines simultaneously. These heavy, powerful military aircraft were considered state-of-the-art for their time. Their mission that day was remarkably simple, a routine training flight codenamed Flight 19. The squadron's planned route was to fly east to conduct a mock bombing run over a coral reef, head north over Grand Bahama Island, and finally turn west to return to base. The Florida sky that day was clear, offering ideal visibility with only a few scattered clouds. Leading the flight was Lieutenant Charles Taylor, a veteran pilot with over 2,500 accumulated flight hours. With an ideal flight formation and such an experienced commander, no one in air traffic control could have foreseen a disastrous outcome. Yet the ocean always knows how to hide its perils. Less than 2 hours after takeoff, the first radio transmissions from Flight 19 left the ground crew utterly stunned. Lieutenant Taylor's voice on the radio lacked its usual confidence, replaced instead by extreme confusion, anxiety, and mounting panic. He reported that he could not see land and that his navigation systems had completely lost direction. Fort Lauderdale Air Traffic Control immediately radioed back asking for his position, but they were met with a haunting, protracted silence. The weather outside remained perfectly bright. Theoretically, the airbase should have still caught glimpses of the squadron on the horizon. Yet looking out over the eastern sea, there was absolutely nothing. A few minutes later, the radio crackled back to life with bizarre words. "We cannot be sure where we are. Everything looks strange, even the ocean." Nearly an hour later, the chaos reached its peak, as other pilots in the squadron began arguing, shouting over the radio in sheer panic. "We cannot find west. Everything is wrong." Right before the signal went completely dead, one pilot managed to broadcast a final chilling sentence. "It looks like we are entering white water. We are completely lost." Facing the imminent loss of 5 aircraft and 14 crew members, the U.S. Navy immediately dispatched a massive Martin Mariner flying boat to search for them. But the next chapter of the nightmare was just beginning. Just 10 minutes after takeoff and reporting its position, the rescue plane abruptly vanished from radar screens, its radio transmissions silenced forever. In a span of just 30 minutes, 6 military aircraft and 27 human beings had vanished from the face of the earth without a trace. In the days that followed, a massive search operation unprecedented in history was launched. The U.S. Navy and Coast Guard scoured over 250,000 damn square miles of ocean from the Gulf of Mexico to the deepest corners of the Atlantic. Yet the result was a definitive zero. Not a single piece of wreckage was found, no oil slicks, no life jackets. Absolutely nothing to prove those 27 men had ever existed. The disappearance of Flight 19 served as the opening salvo that transformed a vast triangular expanse of ocean connecting Miami, Bermuda, and Puerto Rico into a global terror known as the Bermuda Triangle, or the Devil's Triangle. For decades to follow, sensationalist headlines and folklore spun wild theories of supernatural forces, underwater alien bases hidden in deep ocean trenches, or even residual energy from the sunken civilization of Atlantis pulling ships and planes to their doom. But does a malevolent force truly exist here? Or can science dissect this mystery through geology, meteorology, and a chain of human errors? To find out, we must discard the sensationalism and look directly at the hard scientific data hidden deep beneath the ocean waves. To decode why experienced pilots and seasoned sailors could so easily lose their bearings in the Bermuda Triangle, we must address the first hidden enemy: magnetic anomalies and crazy compasses. In maritime and aviation navigation, a compass is a lifeline, the only set of eyes allowing humans to orient themselves across a featureless ocean. However, most people harbor a fundamental misunderstanding. They assume a compass needle always points precisely to the Earth's true north. In reality, there are two entirely different concepts: geographic north, the actual rotational axis of the Earth, where all longitudinal lines converge at a single point; magnetic north, the point toward which the Earth's magnetic field lines point. These 2 points do not align. In fact, they are separated by a massive distance of roughly 1,200 miles. Normally, when traveling across the globe, pilots use calibration charts to calculate and correct for this variation. However, the Bermuda Triangle is one of the very few anomalous locations on the planet where the magnetic field becomes severely distorted. In certain sectors of this triangle, a compass needle stops pointing toward magnetic north and abruptly shifts to align directly with geographic true north. This sudden uncorrected shift creates catastrophic navigation errors. If an aircraft's compass is off by just 1 degree after a few hours of flight, it will be pushed dozens or even hundreds of miles off course, heading out into the open ocean instead of toward mainland safety. What invisible force warps the magnetic field here? After years of surveying, geologists found the answer buried beneath layers of seafloor sediment. Millions of years ago, a massive underwater volcano erupted violently, and its cooled lava flows formed what is now the island of Bermuda. When this volcano went extinct, it left behind a menacing geological legacy. Massive basalt rock formations stretching for hundreds of miles under the ocean. Basalt born from the Earth's core magma contains an exceptionally high concentration of minerals like iron, and most notably magnetite. Magnetite is the most powerfully magnetic naturally occurring mineral on Earth. Modern geological measurements estimate that roughly 500 billion tons of magnetite sit concentrated within the basalt layers surrounding the waters of Bermuda. This half-a-trillion-ton magnetic anomaly lies hidden directly beneath bustling flight paths and shipping lanes. When aircraft fly over the area, the potent magnetic pull radiating from the seabed directly disrupts sensitive cockpit instruments. Researchers have demonstrated that the sheer volume of magnetite in this zone can cause mechanical compasses to deviate by up to 10 degrees, with an impact zone extending up to 200 miles from the main island. This brings us back to Flight 19. Investigators later came to believe that the entire compass system across all 5 aircraft failed simultaneously due to this local magnetic anomaly. With his compasses broken, Lieutenant Charles Taylor fell into a classic aviation visual trap. Looking down from above, the geography of Grand Bahama Island looks remarkably similar to the Florida Keys. Convinced by his faulty instrumentation that he had inadvertently flown too far south, Taylor assumed that turning northeast would cut across the Florida peninsula and take them home. In a brutal twist of reality, they were actually right on their initial northern track. Taylor's command to turn northeast inadvertently steered the entire squadron directly out into the empty expanse of the Atlantic Ocean. They flew in vain until their fuel tanks ran completely dry, plunging the heavy aircraft into the unforgiving waves. If magnetic anomalies and volcanic rocks merely act as deceptive path hiders, the next hypothesis can be likened to an invisible assassin capable of eliminating targets within seconds: methane blowouts. To understand this phenomenon, we must plunge deep into the abyssal ocean trenches of the Bermuda Triangle, where sunlight never penetrates. Here, crushing hydrostatic pressure combined with the near-freezing temperatures of the deep sea creates the perfect environment to trap immense quantities of methane gas in a solid ice-like crystalline compound called methane hydrate, or fiery ice. This methane, generated by the decomposition of ancient organic matter over millions of years, remains tightly compressed and locked beneath layers of deep-sea sediment. However, the structure of the seafloor is not permanent. The Earth is constantly moving, and this region is no exception. Minor earthquakes, tectonic plate shifts, or underwater landslides along continental slopes can suddenly disrupt the pressure sealing these massive methane pockets. Once uncompressed, the solid methane hydrate and instantly destabilizes, reverting violently back into its gaseous state. Imagine opening a warm bottle of soda after shaking it vigorously. The gas explodes and surges upward. Beneath the ocean, this phenomenon generates colossal columns of methane gas that bubble rapidly and shoot toward the surface at blinding speeds. When these gas columns breach the ocean surface, they trigger a dual catastrophe for both ships and planes. The threat to ships. A vessel floats on the ocean thanks to Archimedes' principle of buoyancy, which relies directly on the density and specific gravity of seawater. When a massive volume of methane gas erupts, it instantly transforms dense supportive seawater into a highly aerated frothy mixture of water and gas bubbles, foamy water. The density of this water drops drastically. It becomes too thin to provide any upward buoyant force. If a ship, no matter how massive or heavily armored, happens to sail directly into the center of this localized water aeration, its buoyancy vanishes in an instant. The vessel will lose its equilibrium and sink straight into the ocean depths like a dropped stone. It happens so quickly that the crew has no time to comprehend the situation, let alone broadcast an SOS distress signal or deploy lifeboats. This explains why numerous ships have vanished without leaving behind a single trace or message. The threat to aircraft. The danger does not stop at the surface. Methane gas escaping the ocean does not dissipate immediately. It continues to rise straight up into the atmosphere, forming an invisible yet highly volatile gas cloud. Methane is exceptionally lightweight and highly flammable. When an aircraft cruising through the sky cuts directly through one of these invisible methane plumes, disaster strikes. Aircraft engines require a steady supply of oxygen from the air to combust fuel within their cylinders or turbines. Sucking in a massive pocket of methane instead of normal air completely shatters this oxygen balance. Far worse than simply choking or stalling the engine, the highly flammable methane gas hits the extreme heat inside the engine's combustion chamber, triggering a catastrophic mid-air explosion. Scientists emphasize that for a methane plume rising from the sea to remain concentrated enough to ignite an aircraft engine, the plane must be flying at an exceptionally low altitude. This detail aligns eerily well with the disappearance of the Star Tiger airliner on January 30th, 1948. Belonging to British South American Airways. The plane carried 31 passengers and crew en route to Bermuda, facing severe headwinds at high altitudes. Captain Brian McMillan, a veteran World War II pilot, made a tactical decision. He dropped the aircraft to an ultra-low altitude of just 2,000 feet above the water to exploit a pocket of calmer wind. The Star Tiger flew through the late-night darkness just above the Atlantic. At 3:15 a.m., they checked in with control, reporting everything was normal. Minutes later, the plane vanished without a trace. Could a massive invisible pocket of erupted methane gas have swallowed the low-flying Star Tiger's engines? It remains a scientifically sound possibility. However, if we only blame mysterious natural phenomena or gas eruptions from the ocean floor, we overlook the most critical factor in any journey: human beings and the limitations of technology. We must contextualize the historical reality that the most shocking disappearances within the Bermuda Triangle occurred primarily during the 1940s and 1950s. This was the post-World War II era, a time when commercial and civil transoceanic aviation was in its infancy. There were no global GPS satellite navigation networks, no long-range digital radar systems, and no advanced flight computers to automatically correct a pilot's mistakes. Pilots of that era navigated entirely by cross-referencing rudimentary mechanical instruments, observing visual landmarks, and plotting their position based on dead reckoning, calculating speed against elapsed time. When flying over a boundless ocean at night with no streetlights, no mountains, and no buildings to serve as reference points, a pilot's vision is enveloped by a monotonous pitch-black void. In this environment, a highly dangerous aviation psychological phenomenon easily takes hold: spatial disorientation or pilot vertigo. When this occurs, the human brain completely loses the ability to differentiate between sky and sea, up and down. Many pilots, catching sight of the night stars reflecting perfectly off a glassy ocean surface, mistakenly believe they are looking up at the night sky. In their confusion, they might steer the plane directly downward into the sea while firmly believing they are climbing higher. Consider the disappearance of the DC-3 passenger airliner on the night of December 27, 1948, which perfectly illustrates the deadly intersection of technical failure and human error. The commercial flight was heading from San Juan, Puerto Rico back to Miami with 32 people on board. Even while parked on the tarmac in San Juan, the aircraft exhibited severe electrical issues. The landing gear indicator light failed, and upon inspection, technicians discovered that the plane's battery was completely drained of electrical charge. Ground engineers explicitly warned Captain Bob Lindquist that fully recharging the battery system would take several hours. Lindquist, likely rushing to keep his schedule and make it home, made a fateful subjective decision, he stated. He would simply recharge the battery using the plane's onboard generators once they were airborne. To make matters worse, right before taxiing to the runway, another issue arose. The radio transmitter used for communication began malfunctioning due to the low power supply. The aircraft could receive incoming signals, but was unable to voice broadcast out. After waiting briefly at the end of the runway to pick up a minimal temporary charge for the radio, the DC-3 was cleared for takeoff at 10 p.m. As predicted, the unstable power supply triggered a chain of navigational failures. About an hour into the flight, the captain transmitted a routine position report. The air traffic control tower in Miami, 700 miles away, picked up the signal, but the tower in San Juan, which was right nearby, received absolutely nothing. This proved the radio transmitter was operating erratically. During the final phase of the flight, when the DC-3 was only 50 miles away from Miami and preparing to descend, the captain sent a final altitude report. Bizarrely, this signal was completely missed by Miami, but was picked up by an air traffic control station all the way in New Orleans, 600 miles away, which then forwarded the message to Miami. After that message, Miami repeatedly tried to contact the DC-3, but they were answered only by the empty hiss of radio static. The DC-3 never landed in Miami that night. Investigators later concluded that the weak battery system completely failed mid-flight, killing the aircraft's navigation system's electronic compasses and radio communications. High above the Bahamas in the dead of night, the pilots were completely blind. They had no idea where they were heading, could not see the water, and ultimately drifted hundreds of miles off course into the deep ocean. The plane eventually ran out of fuel and ditched into the Atlantic, leaving rescue teams with no way to locate them. Whether magnetic anomalies are real methane gas erupts, or human error occurs, if you ask any meteorologist or maritime expert about the most practical and devastating cause behind the disappearances in the Bermuda Triangle, their answer will be unanimous: extreme weather and Atlantic hurricanes. This region is far from a peaceful tropical paradise. It is a meteorological funnel, a convergence zone for some of the most violent climate phenomena on Earth. To understand the sheer hostility of the weather here, we must trace the origin of these storms thousands of miles away to the western coast of Africa. Here, a classic climatic conflict unfolds. Daily hot, dry air blowing off the Sahara Desert collides directly with the cool, moisture-laden air over the Atlantic Ocean. The clash of these opposing air masses creates massive atmospheric instability, spawning severe thunderstorms, lightning, and the early seeds of tropical depressions. Guided by global wind patterns and ocean currents, these infant storms begin a long journey across the Atlantic, heading straight toward the West Indies and the gates of the Bermuda Triangle. During this journey, spanning thousands of miles of open water, these storms act like monsters being continuously fed. The southern Atlantic is home to warm, rapidly evaporating waters that release immense thermal energy and moisture into the air. This serves as pure fuel for a developing storm. The longer a hurricane travels over these warm waters, the more energy it absorbs, its cyclonic vortices spinning faster, and its wind speeds escalating. By the time these storm clouds officially cross into the boundaries of the Bermuda Triangle, they have evolved from standard rain squalls into catastrophic Category 4 or Category 5 hurricanes. Imagine the 1940s when pilots took off without the aid of real-time satellite weather imaging to warn them of a storm ahead. They would fly into the triangle guided by a clear weather forecast, only to slam headfirst into the eye of a raging tempest a few hours later. The sustained winds inside these hurricanes can exceed 200 kilometers per hour, accompanied by violent vertical wind shears that can snap an aircraft's wings in an instant. Furthermore, even for the most sturdily built ships on the water, these tempests can generate rogue waves rising up to 30 meters high, equivalent to a 10-story building. These wall of water anomalies crash down upon a ship's deck, shattering its structure and sinking it in the blink of an eye. Once the storm passes the relentless power of the Gulf Stream, a swift, powerful ocean current running right through the Bermuda Triangle rapidly sweeps away wreckage, debris, and bodies, dispersing them hundreds of miles away into the wider ocean. When rescue teams finally arrive, they find only a calm, empty ocean surface, leaving humanity with an enduring, artificially amplified mystery. After a long journey of dissecting layers of data across geology, chemistry, and meteorology, it is time to reevaluate the entire mystery of the Bermuda Triangle through an objective, level-headed lens. Science does not deny that tragic accidents have occurred within this maritime zone. It is estimated that roughly 50 to 100 aircraft and hundreds of ships have been lost to the depths of this triangle over the past century. But does that statistical reality truly make this a realm cursed by supernatural forces? The definitive answer is no. To maintain a fair perspective, we must view the Bermuda Triangle in the context of global commerce and transit. This region connects North and South America, acts as a primary gateway to the affluent Caribbean, and forms the shortest maritime shipping route from the Americas to Europe. The density of commercial shipping lanes, cruise lines, and civil or military flight paths crossing this triangle daily is staggering, among the highest in the world. According to official statistics compiled by major global marine insurance syndicates, such as Lloyd's of London, the percentage of accidents and disappearances within the Bermuda Triangle relative to the total volume of traffic, is no higher than any other heavily trafficked maritime route on Earth from the North Sea of Europe to the busy shipping lanes of Asia. The mystery of the Bermuda Triangle did not originate from the ocean itself. It was born from the pens of sensationalist writers' television programs capitalizing on the macabre and a primal human fear of the vast unknown of the sea. Media outlets selectively curated the most peculiar accidents, systematically omitting critical technical context, such as the DC-3's failed battery, the Star Tiger's low-altitude flight pattern, or Lieutenant Taylor's geographic disorientation during Flight 19. They bundled these disparate tragedies together under a single highly marketable banner, the Curse of the Devil's Triangle. This continuous sensationalism over many decades manufactured an artificial myth out of a completely natural geographical area. What is our final verdict? The Bermuda Triangle is a completely natural body of water. It contains no wormholes, no alien abductions, and no ancient magic. Its danger lies in a far more grounded reality, a perfect storm of volatile environmental factors. It is an ocean basin packed with magnetic rock that distorts compasses, a seabed prone to sudden buoyancy-killing methane blowouts, and a natural funnel for the most violent hurricanes the Atlantic can produce. When humans navigated this unforgiving environment using the rudimentary, unrefined technologies of the mid-20th century, compounded by moments of human error and hubris, the price of admission was occasionally their lives. Today, hundreds of modern passenger airliners fly safely over the airspace of Bermuda at 35,000 feet daily, backed by continuous GPS satellite navigation, advanced digital radar systems capable of scanning storms hundreds of miles ahead, and massive container ships navigating its currents every hour. Human technology and collective knowledge have illuminated the darkest corners of this ocean. The Bermuda Triangle remains vast and majestic, but it is no longer an inexplicable terror. It stands as a stark, enduring reminder from nature to humanity. The ocean humbles those who disregard its rules, and it will always penalize those who venture into its domain with arrogance and a lack of preparation.